The term Android is commonly used to refer to the operating system, and that's accurate, but it's also incomplete. Android is a complete software platform. It includes the operating system, which is based on Linux, but it's specifically designed to be run on mobile devices, including cell phones and tablets. In addition to the operating system, the Android platform includes an application framework that lets you create and deploy your own custom apps that work on Android phones and tablets and also on computers running the Chrome OS operating system, sometimes known as Chromebooks. There's also support for other kinds of devices. The core framework is for the mobile devices, the phones, tablets, and so on, but there are other supported form factors. Once you learn how to program for Android, you can build apps for all of these kinds of devices. Wearables such as watches, apps that run on Android Auto, Android TV for television presentations, and Android Things for Internet of Things or IoT devices. The Android SDK includes a compiler that lets you build and package your apps for distribution. It also includes debugging tools that let you test and tune your apps easily. All of those tools are typically exposed through Android Studio, an integrated development environment, or IDE, that's based on IntelliJ IDEA Community Edition. Android Studio is completely free and, as I'll show you later in the course, can be downloaded from Google. In addition to Android Studio, there's a critical new component called the Kotlin plugin. When you install Android Studio, the plugin will already be there, but you might occasionally need to upgrade it, so it's important to know how to find it. The Kotlin plugin is what lets you develop with Kotlin instead of or alongside Java. And throughout this course, I'll be focusing on this newer programming language, Kotlin. Android was originally released many years ago, and you can learn about those early versions at this website, at android.com/history. That will expand automatically to show the most recent version of Android that's displayed on this screen. But using this screen, you can go to any earlier version of Android, and then click the arrow to learn more, and you'll learn about all of the various features that were introduced in that particular version of the product. Following Android 6 Marshmallow, there was Android 7 Nougat, and that has the largest installed base of any of the versions of Android as of the recording of this video, and Android 8 Oreo, released in 2017. The most recent version of Android as of this recording is Android 9 Pie, released in the summer of 2018. It has many new features, including a redesigned gestures vocabulary, improved battery management, support for notches or cutouts that appear on larger phones with edge-to-edge screens, and app actions and slices, which are ways of taking pieces of applications and exposing them to the user in a variety of contexts. Android 9 is the version that I'll be focusing on throughout this course and throughout other courses of this series. But most of the development techniques that I describe are exactly the same and will work across all versions of Android, going at least back to Android 4.4 KitKat. Android developers need at least a basic understanding of the architecture of the operating system and the rest of the platform. Android is designed around a kernel that's built around Linux. It's a version of Linux that's highly optimized for mobile operating systems, made as small as possible so it works well on devices that have constrained CPU and memory capabilities. On top of the kernel, there's the Android runtime and a set of libraries that enable the operating system's behaviors. The next level up is the application framework, which sits on top of the Android runtime and the associated libraries. And finally, at the top, there are the apps themselves, including both those that are included with the operating system and those that the user installs. Let's break down each of these layers. The Linux kernel, again, starts with Linux itself, but then it also has a set of drivers, and these drivers are tuned to the particular hardware that the operating system is running on. There are drivers for audio, camera, display, the keypad, flash memory management, power, Wi-Fi, and so on. It's up to the OEMs, or the manufacturers of the devices, to customize these drivers and make them work for their own hardware. If you're holding an Android device in your hand, the version of Android that's on that device will be a combination of what Google delivers and what the vendor customizes. The next layer is the Android runtime. This includes a collection of core libraries and, critically, the virtual machine, known as ART for Android Runtime. Older devices might have an older virtual machine that was known as Dalvik, but you don't have to do anything special when you compile and package your apps. Your app will run on both virtual machines. The contemporary Android Runtime, or ART, uses ahead-of-time compilation, so apps are compiled into machine code upon installation in older versions of Android, but in newer versions, starting with Android 7, they're recompiled into machine language the first time you open the app. To build and package an Android app, you use the compiler that's included with the Android SDK. The compiler looks at your code and at libraries that are provided with the Android SDK. These libraries manage all sorts of features, including graphics, databases, and so on. They work at the same level of the software stack as the core runtime, but they're extensible, so device makers can add their own libraries to this layer. Next is the application framework with modules for controlling all the different components of your apps, but then there are the apps themselves. Each version of Android, as packaged by Google, has been delivered with an expanded set of default apps. If a device is licensed to use Google's G Suite app collection, it'll have Gmail, Hangouts, Google Maps, and so on. Devices that use customized versions of Android, such as Amazon's Kindle Fire lineup, will have a different set of default apps. But at minimum, every version of Android typically has a home or launcher screen, a browser, contact and calendar management, and photo and camera management. An app is made up of components, and there are many different kinds of components, but I'll be focusing on the basics. Activities, which represent screens on phones and tablets, views, which are individual visual components, and view groups. Each of these components is implemented in the SDK as a Java class. So, for example, an activity, or a screen, is an instance of a class named Android.app.activity, or some subclass of that class. And a button, or a text view or other visual widget, is also an instance of a class. The button is an instance of Android.widget.button. And you can use these classes either using Java code or Kotlin. For example, if you wanted to create an instance of a button class in Java, the code might look like this, while in Kotlin it would be a bit shorter and would eliminate extraneous syntax such as semicolons. Either way, you're still using the same components that are packaged with the SDK, and it's up to you as the developer to decide how to put those components together to create your own apps. The Android Application Framework is built around the Java Developer Kit, or JDK. Recent versions of Java use OpenJDK, an open-source implementation of Java from Oracle. When you're working in Java, you have to pay attention to what syntax is supported. For example, Java 5 and 6 syntax is pretty much supported universally, and most Java 7 syntax works as well. A lot of Java 8 syntax features will work when your project is configured for it, such as Lambda expressions and method references and so on. But when you work with Kotlin, as I'll be doing throughout this series, you don't have to worry about any of that. All Kotlin syntax is supported in Android, and then it simply becomes a question of which APIs and libraries are available when you're working in Android. The Android SDK includes implementations of many standard Java APIs. These typically start with Java period and include things like java.lang and java.text and java.util. And there are also many APIs and libraries that are specific to Android. The ones that are part of the SDK start with Android dot, and the ones that are part of the support libraries or the Jetpack libraries now start with Android X. But all of these are available whenever you create a brand new project in Android Studio. To learn about how to use any of these classes or interfaces, look at the API reference at this URL. And here you can search for whatever class you need to learn about. When you create a brand new project, you'll choose your primary language, either Java or Kotlin. A Java project can include Kotlin-based classes, but you might have to do some special configuration on the project after it's been created. In contrast, a Kotlin-based project can contain Java classes from the beginning. Kotlin, by its nature, is always working with both Kotlin classes and Java classes, especially those classes that are a part of the core SDK. There are a lot of differences between Java and Kotlin, but many of them can be boiled down to this. This is how you would declare an instance of a class in Java. You'd start with the type, then the name of the variable, and then on the right side of the assignment operator, the keyword new, then the constructor method of the class, followed by the required semicolon. The same operation in Kotlin would look like this. You start your variable declaration with either val or var, then you have the name of the variable, and then the constructor. Notice you don't have to explicitly declare the type of the variable in Kotlin. In this example, the type is inferred from the constructor. Also notice that there's no semicolon at the end of the line, because semicolons in Kotlin are optional. There are a lot of other differences between Java and Kotlin, but the most important one is that Kotlin is simply less verbose. It takes less code to get the work done. When you build your classes in Java, here's how the compilation process works. You start off with your source code and code that's already compiled and provided to you in the form of libraries. All that code is combined together to create a special kind of bytecode called DEX. This is the bytecode that's actually installed on the Android device. And then at runtime, that is interpreted into machine code that works on that particular device. When you program in Kotlin, you're taking your source code, and Kotlin classes end with .kt instead of .java, and once again your library code. All that code is compiled together and turned into Java-based bytecode, and then from there into DEX bytecode. At the end of the day, the device itself doesn't care whether you programmed in Java or in Kotlin. They both turn into DEX-based bytecode, which is installed on the device and then interpreted for that device. From there, the DEX bytecode is translated to machine code, and what kind of machine code depends on the processor and a lot of other factors on the hardware itself. On older versions of Android, there was a runtime engine called Dalvik, and translation was just in time. That is, the DEX bytecode was only translated into machine code the first time the application was run. On more recent versions of Android, there's a new runtime engine called ART, or Android Runtime, and the translation into machine code happens ahead of time. When exactly depends on the version of Android, but it means that applications simply start up faster on these more recent versions. So whether you program in Java or in Kotlin, your code is turned into something that the Android device can read and execute. It's your job as the developer to learn all you can about your particular language, Java or Kotlin, so you can execute the tasks that are needed for your applications. Android Studio is available for free from the developer website at developer.android.com/studio. This page will show you a link for the most recent stable version of Android Studio. As of the time of this recording, that was Android Studio 3.2.1. When you download this version, you'll get a DMG file. If you want a more recent version, say a beta or a canary release, you can download those from the preview link. As of the time of this recording, there were 2 preview releases available: a release candidate for version 3.3 and a canary build for version 3.4. A canary build is a very early release. It hasn't been fully tested, but because there are significant visual changes between the release candidate 3.3 and 3.4, I'm going to be recording this course with 3.4. When you download Android Studio from this page, you'll get a zip file. Now, if you got a DMG file, here's how you install it. Open up the DMG, and then simply click and drag Android Studio into the Applications directory. Now, if you're working with a zip file from the preview page, double-click it, and that will extract it to the same location. The resulting package will have the word preview or beta in it. That will extract a package that's labeled with the version and the word preview or beta. And then once again, you can simply move this file into your Applications directory. Now, I've already done those steps, so I'll go to my Applications directory and show that I have 2 versions of Studio. That's the stable release and the canary release. I'll double-click on the canary release marked as preview, and the first time you do this, you might see a security prompt from macOS indicating that this was just downloaded from the internet. If you see that prompt, accept it. Then, if you have an older version of Android Studio on your system, you'll be asked whether you want to install the preferences from that version. You can either accept that, or you can choose to not import settings, and that's what I'll do. If there are older versions of the preferences from older versions of Android Studio, you might be prompted to delete them. I'm going to leave them on my system. Finally, you'll get to the Studio Setup Wizard. Click Next, and then click Custom, and Next again. On this screen, you can choose a default UI theme. I'll accept the default of the Light UI, and then on this page you'll be prompted to install various components. If this is the first time you're installing Studio, you should accept all of the checked items. Because I already have a bunch of the SDK installed on my computer, I don't see those as available, and I'll leave all of these unchecked. Also notice the location of your Android SDK. By default, this goes into your library/Android/SDK directory under your home directory, and I recommend accepting that location. Click Next, and then click Finish. If this is the first time you're installing Studio, take a break. It's going to take some time to download everything. But if you already have the SDK installed as I do, you can click Finish, and you'll be taken to the Android Studio welcome screen. To get started building Android apps using Windows, download Android Studio for Windows from developer.android.com/studio. As I mentioned in a previous video, at any given time there can be more than one version of Studio available. The version on this page will always be the most recent stable release. And if you download this version, you'll get an MSI file. That's a conventional Windows installer. Simply double-click that file, run the installer, and follow it to install Android Studio in a conventional way. But if you're going to use a preview release, as I'm going to be using for this series, click the Preview tab and then choose the version you want. As of the time of this recording, there were 2 versions available: Android Studio 3.3 Beta 1 and 3.4 Canary 2. The Canary releases aren't always entirely stable, so I'm going to be working with the beta version. When you download Android Studio from this screen, you'll get zip files. And to install the software, simply extract the contents of the zip file anywhere on your hard disk. Now, I've placed my files under Program Files/Android. And I've renamed the directory that contains those files as Android Studio 3.3. To start Android Studio after extracting it from a zip file, go to the bin directory, and then locate either the Studio application, if you're working with 32-bit Windows, or Studio 64 if you're working with 64-bit Windows. It's important to mention that 32-bit Windows is not as well supported as it has been in the past, so I strongly recommend using 64-bit Windows if you can. As you try to start the software up, if you have a previous version of Studio installed on your computer, you'll see this screen asking if you want to import the settings from the old version. I'm not going to do that. I'm going to select this option and click OK. Next, I'll be asked if I want to delete old settings. I'm still using this older version of Android Studio sometimes, so I won't remove it, but this is a great tool for cleaning up old settings directories. Next, you'll see the Android Studio Setup Wizard. Click Next, and then select Custom, so you can set certain configurations. There are two available UI themes, and I'm going to select the default, the lighter theme simply named IntelliJ. Next, I'll be asked whether I want to install various components. If this is the first time you're installing Android Studio, you'll see all of these options are enabled, and you want to keep them all selected. Also, critically, you'll want to install the Haxum software. This is software from Intel that enables fast execution of virtual devices on the Android emulator. Now, I'm going to deselect that option for now because I'm going to show you how to install Haxum separately later. And I'll click Next and click Finish. Then I'll click Finish again, and now you're on the Android Studio welcome screen, where you can create a new project, open existing projects, and execute other critical tasks. Android Studio is updated frequently, and you'll need to know how to manage those updates. The updates are always optional, and there are many times when you may want to freeze your version of Studio and its associated components. For example, when you're getting ready to release a particular version of the app and you don't want to change your version of the tools. But barring those considerations, it's a good idea to keep up with the constant improvements that Google makes to the product. There are a few ways to manage the updates. Each time you start Android Studio, it checks over the web to see if there are updates available, and if so, you'll see this Events notification in the welcome screen. You can click the notification, and then click Update, and you'll see a description of what's available. So, for example, when I was recording on one day, I had Canary 7, and now Canary 8 has been released, and I can choose whether to accept it. You can also check updates manually by going to the Configure menu from the welcome screen and choosing Check for Updates. And once again, you'll see the same information. Updates are offered through a number of channels. You can find your channels by clicking the Configure link on either of those dialogues. I've configured this version of Android Studio to watch the Canary channel. The 4 channels work like this. The Stable channel only delivers components that are fully tested and considered ready for production. The Beta and Dev channels have versions that are fully tested and are being prepared for stable release, and the Canary channel has software with all the latest features and bug fixes, but it might not be ready for prime time. Now, since you can have more than one version of Android Studio installed on your computer at the same time, I recommend always maintaining one version that only uses stable components. Use that version to build apps you're going to deploy to the public. But to keep up with what's coming in later releases, You can also install a more recent version that's connected to the Canary channel and use that version for learning and experimentation. Here's yet another way to manage your updates. Go to the Configure menu, and from there to Preferences on Mac or Settings on Windows. Open Appearance and Behavior, and System Settings, and then Updates, and once again you'll see the same user interface offering the same options. So that's one aspect of keeping your installation of Android Studio up to date. Another important aspect is managing your plugins, and specifically if you're using Kotlin to develop your apps, you'll need to update your Kotlin plugin regularly. In Android Studio, I'll click the Installed tab, and then from there I'll type Kotlin. I'll click on the Kotlin plugin and check the version that I currently have, and I have 1.3.10. You can also click on the Updates tab and click Check New Updates, and it will check your currently installed plugins for any more recent versions. It's a really good idea to update your Kotlin plugin before you create a new project if you can. If for any reason that's not available, you might be prompted to update the plugin when you're working in the project itself, and I'll show you how to deal with that in a later video. When you build and package Android apps, you're depending on the Android SDK, and you can manage your installation of the SDK through an interface called the SDK Manager. Open the SDK Manager by clicking Configure and then SDK Manager. You can also get here through the Preferences or Settings link, or if you already have an Android project open, you can get here from the menu. The SDK Manager has 3 tabs, labeled SDK Platforms, SDK Tools, and SDK Update Sites. Of these, you only need to deal with the first 2. The SDK Platforms tab shows you the different versions of Android that you have available. They're labeled by the Android version number, but also by what's known as the API level. The end user knows about the version number and the version name. For example, Android 9.0 is Pie, Android 8 and 8.1 are Oreo, and so on. But for the developer, the API level is what's important. You can find the details of what you have installed by clicking the checkbox at the bottom right. And you'll see that for Android 9, I currently have installed the SDK platform, the source code for the SDK, and one system image. In this case, I'm using the Google Play Intel x86 system image, and that's what you use when you run a virtual device in the Android emulator. I recommend having at least one of these installed. On your system, you should minimally have these components installed. You might have a more recent revision, shown over here, or if you're watching this course much later, there might be a newer version of Android available, and that's fine. You only need to install the SDK platform for versions of Android that you're testing on using a virtual device. So for example, if I have a virtual device that's going to be using Android 8, I might also install the Android SDK Platform 26, and then I would install the system image for the emulator. I'm not going to do that right now, so I'll uncheck those options. The SDK Tools tab shows other components that are critical to building your application. Once again, I'm going to click Show Package Details to show everything that's installed. The Build Tools version should always be set to the most recent version available. In the most recent versions of Android Studio, the version of the Build Tools is selected automatically by Studio, so you don't have to configure your project to work with a particular version of the Build Tools, and most of the time you can have only one version installed. Other critical components include the Android emulator and the SDK platform tools and tools packages. I'll talk about those in a separate video. You'll need the Intel x86 emulator accelerator, to make it work as fast as it's capable of working, and you'll also need some other tools that are shown down here. When you open this tab, if you see any prompts to update the components, I recommend always accepting them. You can also see up here the location of your SDK, and if you need to change the version of the SDK, you can click Edit and then change it here. I'll cancel out of that dialog. Knowing your way around the SDK Manager is critical. It's where you manage all the different versions of the libraries and components that you use to create and package your Android apps. The Android emulator, where you run virtual devices, depends on a software package from Intel known as the Hardware Accelerated Execution Manager, typically referred to by its acronym HAXM, H-A-X-M. HAXM is installed on your computer automatically when you first install Android Studio, but there are times when you'll need to reinstall or upgrade it yourself, and there's a couple of ways to do that. One approach is to download HAXM through the SDK Manager. I'm on the SDK Tools tab that I showed in a previous video, and I'm showing that I've installed the HAXM installer, version 7.3.2. You might have a more recent version on your computer. Now that only indicates that I've downloaded the installer, not that the software is actually installed. And so, in order to use the installer, you need to go to your SDK directory. You can find the SDK directory up here, so I'll copy this to the clipboard. Then I'll get out of this dialog and minimize Android Studio. And then in Finder on Mac or in Explorer on Windows, I'll go to that directory. From there, I'll go to Extras, to Intel, to the Hardware Accelerated Execution Manager directory. And I'll find the installer is here. On Mac OS, you'll find a DMG file, and you can open the DMG file and then run the installation from there. If you're on Windows, you'll find an MSI file, and once again you can run the installation. If you have any trouble installing HAXM using the installer provided by Google, you can always find the more recent version of the software at this website. You'll find versions of the software for Windows, for Mac OS, and for Linux. You'll also see that there's a link for an installation guide and system requirements for all three operating systems. One other important note about HAXM. In the past, the software's installer asked you to decide how much RAM to allocate to the emulator and its virtual devices. In the more recent versions, though, memory allocation is dynamic, so the installer does its thing without having to ask you any questions. Just install the software, and you'll be ready to run the Android emulator on all supported operating systems. To create a new Android app, you'll create a project in Android Studio. From the welcome screen, click on the first option, and now you're asked to select your beginning template. The template will determine what your screen looks like. Each screen in an Android app designed for phones and tablets is called an activity. An activity is simply something that the application will do, and on a phone and tablet it has a visual component. There are a number of templates available, from the simplest like the basic and empty activities, all the way down to the much more complex activities. For this demonstration, I'm going to choose the basic activity. It has a simple bit of text in the center of the screen and a widget called a floating action button in the lower right corner. I'll choose that template and click Next. On this screen, you're asked for the application name, and it can be anything you like. I'll call my app My First App. The package name is a universally unique ID. Each app in the Google Play Store or other app stores has to have this global unique ID. It's a simple string, but typically it's set up with reverse domain notation. So the first part of the string is your organization, using reverse domain notation just like with a Java package, and then after that, some string that identifies the application itself, usually in all lowercase. I'm going to keep this example of com.example.myfirstapp, and I'll use that unique package name throughout this course. Next, you select the location of the project. The default location is in a directory called Android Studio Projects under your home directory, but it can be anywhere on your hard disk. It is recommended that you choose a directory location that doesn't have any spaces in the names. Next, choose your programming language, and you can select either Java or Kotlin. I'm going to choose Kotlin and use that language throughout the course. The minimum API level determines which devices your app will be able to run on. This screen will default to API 15, but as of late 2018, Google recommends a minimum of API 16, because earlier versions of the operating system will no longer support certain features. There are two options down here at the bottom. The first one can be ignored. It's about instant apps, not something we're going to deal with. And the second says use Android X artifacts. I'll explain what Android X artifacts are later on in the course, so for now just leave that unchecked and click Finish. And that will create your application. The first time you create an application, you might see that it takes a while for the application to be built. That's because Android Studio has to download certain components that are identified in your application's configuration. You might also see prompts to update the Kotlin plugin if you're using Kotlin. And if you see that prompt, I recommend installing it, but I'm going to show you something about that in a later video, so I'll leave it alone for the moment. Watch this area down here in the lower center of the screen. As long as there are messages being displayed, that means that the application building process is still going on. When you don't see any other messages, and if you look up here and you see this Run button is active, that means your application is ready to work with. Now, I can't do anything with the application yet because I don't have a device to test it on. So that's all I'm going to demonstrate in this video, and then after I've created or plugged in a device, I'll show you how to run the application from Android Studio. When you're building applications using the Kotlin programming language, you're using the Kotlin plugin in Android Studio, and periodically that plugin will be upgraded by Google. When that happens, you'll see a notification pop up like this one. In order to upgrade any plugin, you'll first install the plugin and then restart Android Studio. And then in the case of the Kotlin plugin, you'll need to make a change to your application configuration. I'll click Install, and then I'll wait a moment while the new version of the plugin is downloaded to my system and installed in my Android Studio installation. Then when prompted, I'll click the link to restart Android Studio. It'll take a few moments for Android Studio to restart, but when it reappears, it should come back to the same basic layout. And if you see this tip of the day dialog, you can uncheck the option and then close the dialog. If you see other notifications that you want to ignore, move the cursor over the notification and then click the X to close it. Now, my version of Kotlin was just upgraded, but my application was built with the previous version. Here's how you get them back in sync. Over here in what's known as the project window, make sure that you're looking at what's known as the Android scope. Then click the Gradle scripts directory and open this file named build.gradle that's in the project. You don't want this one that's in the module. Open the project version of the Gradle build file. Now, to make this text a little bit easier to read, I'm going to go into Android Studio Preferences or Settings. Then I'll go down here to Editor, to Font, and I'll increase the size of my font. You don't have to do that on your system if you like your font size already. Next, I'm going to look for my Kotlin version. It's currently set to 1.3.10. I'm going to change that to 1.3.11 to match the new version of the plugin that was just installed. And then I'll click the new link that says Sync Now, and I'll wait a few moments for the syncing process to complete. That will download matching components that fit with the new version of the plugin, and then when the process is done, you'll be ready to go back to development. You'll also see another item here that has a warning indicator, and it tells you that the version of the Gradle plugin is not matching the more recently available Alpha 08. Now, the versions you see will be different than what I'm seeing, because you'll probably be using a different version of Android Studio. The Gradle plugin version must match the Android Studio version. I'm using Android Studio 3.4 Canary 7, and that matches Gradle 3.4 Alpha 7. I don't want to upgrade this version unless I'm also upgrading Android Studio. So if you're on the screen and you look up here and you see that the Run button is enabled, once again the app has been successfully built and you're ready to deploy and test it on your devices. Android Studio is based on IntelliJ IDEA Community Edition, a popular Java IDE. The basic layout is exactly the same as IntelliJ, but there are additional tools specifically for Android. In both IntelliJ and in Android Studio, the core window is called the editor window, and it can have multiple tabs so that you can look at multiple files. You can double-click on any of those tabs to expand it to full screen, and there are other full screen options available under the View menu. You can choose the full screen mode, and then you can get out of that by going back to the same option on the menu or by pressing the associated keyboard shortcut. There's also distraction-free mode, which gets rid of a lot more elements of the interface. Once again, I'll exit that. And presentation mode, which can be used when you're doing presentations at conferences or in user groups. Many of the features of Android Studio are available in multiple places. You can find certain features on the menu, and many of the menu choices have associated keyboard shortcuts shown there. You can also look at your files, look at the structure of your files and classes, and get to other functionality using these tabs that are scattered around the window. The number and names of the tabs will change depending on what you're doing at any given time, and also which version of Android Studio you're working in. In this video, I've jumped forward a version. I'm working in Android Studio Canary 9, whereas in earlier videos I was in Canary 7, and this new tab called the Resources tab has suddenly appeared. And that's something you kind of get used to when you work in Android Studio a lot. The environment is updated frequently, and so if you accept all of the offered upgrades, you'll frequently see new features appear. Over here, you'll see a toolbar that has buttons for running and updating and debugging an application, but you can move that toolbar over by selecting View, Toolbar. And now all those features are right here where they're a little bit more easily accessible. When you have a file open, these icons above the editor let you jump to particular packages. So for example, if I go to my base package, I see that there's only one file available. But if I go to the Java package, I see COM under there. If I go to main, I see Java and RES for resources, and I see my Android manifest file. You can also find files easily by using the Search Everywhere feature. Press your Shift key twice, and this dialog will pop up. If you're using an older version of Android Studio, prior to 3.4, this dialog looks a lot different, but the basic functionality is the same. You can jump to particular files by typing any part of the file name. So for example, I wanted to find activitymain.xml, and I'll click it to select it. When you're in a layout file, you'll have tabs at the bottom. allowing you to look at the file and work with it either in design or in text mode. And there are certain other kinds of files that have similar features. For example, I'll go to my project, to my menu directory under Resources, and open menu main.xml, and it opened for me in text mode, but then I can look at it again using design mode, and this gives me a way of working with these files visually instead of in code. There's a lot to learn about working in Android Studio, and I recommend watching the course Android Studio Essential Training to learn about all the available tricks in the most recent version of this IDE that's critical to Android developers. To test your apps, you'll need either a physical device, that is a phone or a tablet, or a virtual device that you can create for free and run on the Android emulator. Create virtual devices using the AVD Manager. You can get to the AVD Manager from the Welcome screen under the Configure menu, or if you already have a project open, you can open the AVD Manager from the Tools menu. From this screen, click on Create Virtual Device, and then choose the device definition you want to use. You'll find device definitions for various form factors, including Android TV, Wear OS for watches, or phones or tablets. I'm going to create a phone device, and I'm specifically going to emulate the Pixel 2. Now, I'm not using Pixel 3 for a couple of reasons. First of all, the Pixel 3 definition, as of the time of this recording, had a bad bug in it. But more importantly, the Pixel 2 definition has full support for the Google Play Store. That will allow me, if I want to log into the Play Store using my own Google credentials and download apps from the Play Store onto the virtual device. This is only available on device definitions that have this icon in the Play Store column. I'll click Next, and then I'll choose a system image for the version of Android that I want to emulate. If you don't see one available, you can click on the download link and download the system image that you need. I've already downloaded the Pi image, so I'll choose it and click Next. This screen allows you to manage various configurations for your virtual device, and you can see them all by clicking on the Show Advanced Settings button and scrolling down. The most important thing when you're working with a virtual device is to make sure that you've enabled keyboard input, so you can type values from your development system keyboard rather than depending on the on-screen keyboard. Click Finish, and your new virtual device should appear. Then launch the device by clicking on the Run button under Actions. You can then close this dialog and wait a moment while your device starts up. It might take a few moments to start up for the first time, but then once the device is completely ready, you can connect Android Studio to the device so that you can launch apps. To do that, go back to Android Studio, and down at the bottom of the screen you should see a tab labeled Logcat. Its position will differ depending on your system configuration, but click it. The Logcat window shows tracing messages flying by. Now these are not important right now, so I'm going to shrink this window down, and now I'm ready to run the application for the first time. On the top right, I'll click on the Run button, and the Select Deployment Target dialog appears. I only have one device right now, and it's selected, so I'll just click OK, and then I'll watch the messages down at the bottom of the screen. As soon as I see a message labeled Installing APK, I'll switch over to the device. And there's my application running on my virtual device. I can control the application with my mouse. For example, I'll click on the floating action button and see the response. And I can resize the device by clicking and dragging on the corners. And I can move it around the screen. So now my virtual device is ready to use for testing and running my Android apps. You can create as many different virtual devices as you need to test your apps on various screen sizes and pixel densities. In order to test your apps on a live physical device, you'll need to attach the device to your development computer with a USB cable. On Mac OS, that's all you have to do. The device should immediately be visible to the computer. But on Windows, there are times when you need to install a device driver. On Windows 10, it's very common for the suitable driver to be installed automatically. But on earlier versions of Windows, you might have to do a little bit of extra work. To find out whether your device is automatically supported on Windows 10, connect it to your computer with a USB cable. Then from the Start menu, search for the Device Manager. Devices that are not set up for debugging yet frequently show up under the Portable Devices section. Notice that I have two physical devices currently connected, a Google Pixel phone and a Galaxy Tab tablet. I'm going to look at their drivers. I'll right-click on each of these devices and then go to Properties and then the Driver tab. The Google device is using an older driver from Microsoft dating all the way back to 2006, and it's working fine. I'll come back to that in a moment. The Galaxy Tab device is using a different driver that's specifically from Samsung, and once again is pretty old, going back all the way to 2012, but again is doing the job. Now, if you don't see your devices showing adequate drivers, you can update them. For example, for the Pixel driver, I'll use a driver that's installed along with the Android SDK. I'll go to my Android SDK directory, and from there to Extras, to Google, to the USB driver directory, and I'll find all these different driver files available. I'll go back to the Device Manager, I'll right-click on the Pixel, and choose Update Driver, and then browse my computer for driver software. My directory is already in place, so I'll try clicking Next, and I see the message that Windows has determined that this is the best driver for this device already. If you're using a mobile device from a vendor other than Google, you'll need to find the driver from the device manufacturer's website. The basic file and directory structure, though, should be the same as what I showed. Download the files from the vendor, extract them, and then go through the Windows Device Manager to connect the driver that you need. Whenever I have a choice, I always use a physical device to test and debug my apps. That's because it's faster and more reliable. You'll get a better sense of how your app will really behave on a physical device compared to a virtual device. The first step is to connect your device to your development computer using a USB cable. Then, to find out whether the device is already set up for debugging, go to your Logcat window. If you see no connected devices, then that means you have some setup to do. I'm demonstrating this using a Pixel device running Android 9. The location of some of the menu choices I'm going to show will differ depending on the vendor and the version of Android, but the basic steps usually look like this. First, go to Settings. Now, go to your system, and from there on Android 9, go to Advanced. Scroll until you find the build number, and then touch build number 7 times. Each time you press it, you might see a message such as you are now a certain number of steps from being a developer, and on the 7th touch, you should see the message you are now a developer. Go back 1 step, and you should now see developer options available. In the developer options, turn on these 2 features. Turn on Stay Awake. That will ensure that your phone doesn't go to sleep while you're debugging. Then look for the Debugging section and turn on USB Debugging. If you're prompted to confirm that you want to turn this feature on, touch OK. And then if you see this message asking you to allow USB debugging on this particular computer, touch the option to always allow it and once again touch OK. Now you can exit Settings and then go back to Android Studio, and you should see that your device is connected and ready to use. Now you can run the app on the device following the same steps as with the virtual device. If you set up a virtual device, you should now see both devices available in the Select Deployment Target dialog. Select the physical device and touch OK, and then after a moment you should see the app is loaded on the device. Just as on the virtual device, you should be able to interact with the app by touching the button in the lower right corner. Once again, the steps you'll need to follow will differ depending on the device and the particular version of Android, but you're always looking for the developer options so you can turn on USB debugging so you can test and debug your apps on a physical Android device. As an Android developer, you'll find that you spend most of your time in Android Studio, but there are many situations where knowing how to use Android command line tools can be very useful. First, you'll want to add the SDK's Tools and Platform Tools directories to your system path. They're located here, under your SDK directory. On Mac, that's typically under the Library Android SDK directory under your Home directory, and on Windows, it's wherever you placed it when you installed Android Studio. From here, you'll find the Tools directory, and under there, a bin directory, and there are commands in both of those directories in the most recent releases. And then there's a Platform Tools directory, and this is where the critical tool ADB for Android Debug Bridge is located. If you've never done that before, you can find directions in the course Android Studio Essential Training. Now, to add these directories to your path, on Windows, just add them to your path environment variable. On Mac, you can create a file called bash profile, prefixed with a period in your home directory. And it's best to create this with the editor that's included on Mac called Nano. From the command line, type sudo nano.bash_profile. Now, if the file already exists, you'll be opening it, but if it doesn't, you'll be creating it. If you're prompted for your password, enter it and press return, and then the file will open. And again, if it doesn't yet exist, you'll just see an empty area where you can type. To add the directories to your system path, use export, then path equals $path, and then provide a list of directories. Separate the directories with colon characters. When you're done editing, press Ctrl X and follow any prompts, and then you can close Terminal. Back in Android Studio, whether you're working on Mac or Windows, after you've added these directories to your path, you can go to the Terminal window. You should be able to open Terminal from a tab at the bottom, or if you don't see it, move the cursor over the icon in the lower left and you'll find Terminal there. From here, type ADB devices, and this will give you a list of the devices that are currently attached to your development computer that have USB debugging turned on. If this is the first time you've run the ADB program, you'll see a message go by telling you that ADB is starting up before you see the output. There are many other command line tools available. Check the documentation on the developer website for more details. Google provides extensive documentation for Android developers. It's available at developer.android.com/docs. You'll find tutorials and conceptual documentation under the Guides tab, and for the API documentation, look at the Reference section. From here, the reference documentation is separated into categories. The Android platform includes classes and components that are part of the core API. The Android Support Library section contains components that are delivered separately, that work across Android versions, and Android X contains many of the same components, but they're separated into different packages that start with the phrase Android X. Now, in order to find documentation for any class, click into the search box and type the name of the class. So, for example, I'll go to the activity. I'll find a bunch of references here, and I'll go to android.app.activity, one of the most important classes in the entire SDK. You can now separate the documentation by version of Android by looking at the API level pull-down. Android 9 Pie is API level 28. Going back in time, version 19 is KitKat, Android 4.4. By choosing a different API level in the documentation, when you choose a different API level here, you're filtering the content, so you'll only see the components that were available in that version of Android. Once again, going back to the reference section, components in the Android support library don't have that filter because the support library works across all Android versions. You can also get to the documentation to some extent from within Android Studio. If you go to a component that's part of the platform, that is a part of the core SDK, you can press Shift F1 and jump to the external documentation. So, for example, I'll go to my import statements in this class, and I'll place the cursor in the menu class name and press Shift F1, and I jump to the documentation. That feature doesn't work so well on classes that are parts of the support library or part of Android X. If you try pressing Shift F1 here, you probably won't get a response. But you can press an alternative keyboard shortcut to get some documentation. On Windows, press Ctrl-Q, and on Mac, press F1. And you'll see a little pop-up that appears that shows you the package that the class is a member of. From there, you can press the same keyboard shortcut again, and you'll open up a separate window, and pressing it again moves to the other tab. Pressing it again closes it down. Now, if I go to one of the classes with full documentation from the core platform and press that same keyboard shortcut, I'll get a whole bunch more documentation. And again, I can cycle through the views to see it either in a little window or a larger one. And if this version of the documentation isn't sufficient, then once again you can go to the complete documentation in the external web-based docs. Either way, it's important to be comfortable with the API documentation from Google. Learning how to develop in Android is partially a conceptual matter, but then once you learn the basics, you'll need to be comfortable learning about all the different libraries that offer various functionality for Android apps. Throughout the rest of this course, I'll be working with exercise files that are available for download from GitHub. You don't need to have a GitHub membership in order to download this repository because it's been set to public, but I recommend having one anyway because a lot of components and examples are available through GitHub, and by joining GitHub, you'll be able to participate fully in the Android community. Go to the GitHub repository at the URL shown above, and then click on the Clone or Download button. You'll see a URL that will let you check out this repository. Click the button to copy the URL to the clipboard, and then you can close the browser. Then, in the Android Studio welcome screen, click on the Checkout Project from Version Control link and choose Git. Paste the URL into place, click the Test button to make sure you can connect, and then click Clone. After a moment, you should see this dialog, and you can click Yes to open the project for the first time. If you see this dialog asking if you want to add the vcs.xml file to the repository, click Cancel. It might take a few moments to completely sync up the project, but once that process is complete, you can click the Run button, and you can run the application on your device. Notice that this is a very different application than the one I've been working on. That's because I'm starting in what's known as the master branch. And when working with GitHub, typically you make your changes in a new branch and then merge them back into the master. So the master always has the most recent version of an application. In order to work with other versions of the application, check out various branches. You can get to the branch list in two different ways. From the menu, you can select VCS, Git, Branches, and you'll see this dialog pop up. Or, as I like to do, you can click on this icon at the bottom and see exactly the same dialog in the lower right corner. Click on the Show 26 More link, and now you'll be able to see all the different branches that make up the exercise files. You'll find a starting branch and an ending branch for each video that uses the repository. The starting video will have the chapter and video number, and the ending video will have an E at the end. You can make this a little bit easier to read by clicking at the top and dragging up, and now you can see all the different branches. To start with a new video, click on the branch for that video and click Checkout As. You'll see a new branch name suggested, click OK, and then, if you see this dialog, click on Force Checkout. You should then be able to open up the files and see the files in their current state for this video. If you see problems such as unresolved references, go to the Gradle tab on the right, right-click on the project, and choose Refresh Gradle Project. And after a moment, those issues should be cleaned up because Gradle will have resynced the project and rebuilt the application. You can then run that version of the application on your device, and now the app will look as it should for the beginning of that exercise. At the end of every exercise, check in your changes to your local version of the repository before you try to check out another branch. Click on the Version Control tab at the bottom of the screen, and if you've made any changes, you'll see them listed here under Default Change List. I'm just going to make one little change, adding a hard return here, and then that file is added to the default change list. I can click on that file and press Command-D on Mac or Control-D on Windows, and I'll see a diff display showing me changes between the old and the new file. I can then click on the checkmark icon, and I need to add a commit message. I'll just say My Changes, and then I can click on Commit. If you see any problems, such as warnings and errors, you can review them, or you can just plow ahead and click the Commit button. And now you can go to a new branch and check it out. Notice when I did that, that extra hard return disappeared because it wasn't part of the new branch. So that's a quick tour of working with Git and GitHub in Android Studio. Most of what you need to do with GitHub is supported directly in Android Studio, and it's fairly rare that you have to go to the command line to execute Git commands. But if you do, I recommend watching the courses on Git that are available in the library. Android Studio projects have a specific structure with standard directory and file names. You can access the files through the project window on the left side of your screen, and you can open and close that project window with the keyboard shortcut, which is Command-1 on Mac or Control-1 on Windows. The project window includes multiple scopes. The project scope shows your application's files and folders as they exist on disk, while the other scopes filter this data in different ways. The Android scope only shows you the files and folders that you typically use the most while you're doing application development. I'll go to the project scope and walk through some of the directories. The directories that are prefixed with periods contain configuration files, Gradle for your Gradle plugin, and .idea for the underlying IntelliJ IDEA environment. You won't deal with those directly while you're doing development. Under the app directory, you'll find Source, Main, and this is where your code and resources are for your application. The app directory is a module, and a single project in Android Studio can contain multiple modules. Under the main directory, you'll find a Java directory, and this is where your code lives, regardless of whether you're coding in Kotlin or in Java. And under RES, you'll find your resources, including graphics and XML files. The drawable directory might have XML, JPG, and PNG files all mixed together, while the values directory contains XML files defining various resources: colors, dimensions, strings, and styles. You'll also find directories called Test and Android Test, and these contain components for unit testing. Under Java, you'll find an example of unit test for Java code, and under Android Test, you'll find something called an instrumented test. And this is a way of testing the user interface as opposed to just testing business logic. Under the main directory, in addition to the Java and RES directories, you'll find the application manifest. And this is where you declare your activities and your services that are critical for your application. Now, once again, you're seeing all the files and folders here in the project scope. I recommend using the Android scope, so you see a filtered view that only shows you the files and folders you need while you're developing your app. Your Android app is built or compiled by the Gradle library. Gradle is a build system. It's responsible for compiling your code and packaging the resulting files and your application resources so they can be deployed through the Google Play Store or other app stores. You configure Gradle using files called build.gradle, and when you first create an application, you'll see that there are two versions of the file available, one labeled as the project file and one labeled as the module file. Now, due to a known bug in Android Studio, you might not see both of these files displayed under Gradle scripts when you're in the Android scope. So to find them, I recommend going to the project scope. You'll find the project file here under the project, and then the module file here under the app directory. And I'll open both of them at the same time. The project build.gradle file defines the Gradle plugin version, and if you're working in Kotlin, the version of the Kotlin plugin. It's critical that these files are updated whenever you upgrade either Studio or the Kotlin plugin, so that your configuration file matches the version that you have installed on your development computer. Now, I'm going to show you what happens when you upgrade Android Studio, because you'll find that you do it so frequently. I'll close the project, then I'll go to the Configure menu and check for updates. And at this moment, I have a new version of Android Studio available. That's Canary 9. I'll click Update and Restart, and then after a few moments, after my patch files have been downloaded, Android Studio will restart. After Android Studio has restarted, I'll reopen my project, and as the project opens, it'll be rebuilt automatically. And at that point, Android Studio sees that the configuration of the Android Gradle plugin is out of date and offers to update it for me. I'll click Update, and I'll close this What's New window, and show that the Gradle plugin version has been updated to match the new version of Android Studio. That's the project level file. The app level file is just as critical. This is where you configure your application version. There's a version code, which is always numeric and always an integer, and a version name, which can be any arbitrary string. The version code is how you track your versions of your application internally, while the version name is what the user sees on the App Store. Every time you upgrade the application, you should increment your version code by 1 to make it unique, but then change the version name however it makes sense for you and your audience. The application ID matches the base package where your Java and Kotlin classes are stored. The target SDK version points to an API level. API 28 is Android 9 Pie, and your minimum SDK version indicates the oldest version of Android that this application is approved for. Google currently recommends a minimum SDK version of 16 because older versions of Android are no longer supported by the Google Play support libraries. Down here under Dependencies, you'll see strings representing different libraries that your application is dependent on. Each of these starts with the keyword implementation, and then there's a string indicating which library and which version of the library you're using. When you build your application, the Gradle build library uses these strings to identify the components you need, and it draws some of them from a local Maven repository and others from online repositories. The Maven repositories that are online are identified in your project-level Gradle build file here in the repositories section and also here in the All Projects repositories section. Google points to its own Maven repository, and JCenter points to an open source repository that's also available online. As you get into building more advanced applications, you'll find that you need to update this information. You'll update the module-level Gradle build file most commonly, but every once in a while you will need to deal with the project-level file as well. Each Android Studio project has one or more modules. In a brand new application, you'll typically have just one module representing the application itself. But in a complete production application, you might have one module for the app and then other modules for various libraries that support the app. Each module has a manifest file. Its name is always the same, Android manifest.xml, and it's stored in the manifest subdirectory. It's an XML file. Its root element is called manifest, and it declares at least one XML namespace that's used to identify various attributes in the rest of the file. The package attribute points to the base package for the application, and that will match the package where you've stored your root classes, such as main activity. Within the manifest, you'll find an application element. The application element has a number of useful attributes such as allow backup, labels, icons, and so on. But then there's a whole bunch of other important stuff that happens at the activity element. Each activity in an Android app for phones or tablets represents a particular screen in the application. When you build a brand new application, it'll typically have at least one activity. The name points to a class, whether it's written in Kotlin or Java, and that's the class that controls the behavior of the activity. You can jump to that class by holding down the Command key on Mac or Control on Windows and clicking the class name. The label is displayed in the activity in a couple of different places. For pretty much all activities, you'll see the label displayed at the top, but for activities that have an intent filter where the action is set to main and the category is set to launcher, that string will be displayed on the device's launcher screen, associated with the launcher icon. Each new activity and each new service in the application must be registered in this manifest. I'll create a brand new activity. I'll right-click on the app module and then choose New Activity, and I'll choose the empty activity. That's the simplest template. I'll change the activity name to Detail Activity, and I'll accept all the other attributes, including the source language of Kotlin, and I'll create the activity. When prompted, I'll add that activity to my GitHub repository. Now, that results in creating a Detail Activity class, and also in the Resources folder under Layout, an ActivityDetail.xml layout file. But going back to the manifest, I find that the activity has been automatically registered there. And the same thing will happen when you create a new service. Once again, I'll go through the menu to create a new component. I'll accept all the default settings and click Finish. And once again, that creates a class, but back in the manifest, I see that that component has been registered. When you package your application for deployment, this manifest is included, and the Android operating system and application framework examine the contents of this manifest to determine how to handle the app and its components. Understanding and maintaining the manifest is a critical element of creating Android apps. The Gradle build system, which is integrated into Android Studio, depends on a system known as Maven. A Maven repository is a library of libraries, a place where developers can share libraries and other developers can download them. You declare dependencies in your application's Gradle build file that point to libraries stored in Maven. In your project-level build file, you can declare variables that are used to determine the version of various libraries that you'll be using. But the actual dependencies should be declared in the module build.gradle file. They're down here in the dependencies section, and each starts with the keyword implementation and then is followed by a string. Strings that combine literal values with variables must be wrapped in double quotes. But simple strings, such as the one for the app.compat library, can be wrapped in either single or double quotes. In this application, I have a number of dependencies that use support libraries. A support library contains components and code that are integrated into your application. Because they're stored separately from the primary SDK, they can be backward compatible to older versions of Android. In the legacy versions of the support libraries, which is what are being declared here, the V7 means that these components are compatible back to API level 7. But there's a newer way of declaring these dependencies. Instead of using packages starting with com.android.support, the newer dependency strings start with AndroidX. And you can upgrade your entire application to use those new support library declarations. Go to the menu and select Refactor, Migrate to AndroidX. If you want to back up your project, you can, but I'm going to uncheck that option. Then I'll click Migrate, and that tells Android Studio to scan all of the project's files. In the refactoring preview window that opens at the bottom of the screen, I'm shown all the changes that are going to be made in my files, and when I click Do Refactor, the changes are all made for me. Now, my modules build.gradle file shows dependencies that start with AndroidX. Notice this warning condition is telling me that there are more recent versions of these libraries available. And to fix that, you can place the cursor in any of those strings and then use something called an intention action. On Mac, press Option and Return, and on Windows, press Alt and Enter. And select the change to the newer version of the library. Do that for each of the libraries that shows that warning. Then at the top of the screen, click Sync Now, and that should resync your application with Gradle. Then you can test your application. I'll click the Stop button to stop the application on my device. Then I'll click the Launch button and click OK. And then I'll show that the application successfully launches on the device. So now my dependencies and the support libraries that they refer to are using the newer AndroidX strings, and my application is now set up to work with the latest versions of all of these libraries. The Android Jetpack Collection was announced at the 2018 Google I/O conference. It's a loose collection of software components that are designed to speed up development of Android apps. The Jetpack components are built and delivered in a set of libraries that are prefixed with Android X in their packages. Many of these libraries and components existed before Jetpack and were previously delivered as part of the support libraries. And in fact, if you have an existing application that uses support libraries, Android Studio makes it easy to convert over to Android X. Toward the bottom of this page, you'll find a listing of the components that make up the Jetpack collection. Again, many of these existed previously. The AppCompat components were part of the support libraries, and they're designed to let your application degrade gracefully when you run the app on older versions of Android. These components are delivered as part of the support libraries or as part of Jetpack instead of in the core Android SDK, because Google can't go back and retroactively build old versions of the operating system. On the other hand, many of these are fairly new. The life cycles, live data, navigation, and paging components are part of what's known as the architecture components. These components don't just make development go faster, they make your application more maintainable over time, so that you're not putting all your code, say, in a single activity, sometimes referred to as the God activity. The architecture components encourage you to break down your application using a philosophy called separation of concerns, where you have database functionality in one component, business logic in another, and user interface management in yet another. I describe how to use some of these components in a course on the architecture components. And then there are very specifically targeted components, such as the compatibility APIs for checking permissions, the notifications APIs, APIs for Android Auto, and so on. I recommend getting familiar with the Jetpack components. In the past, Google recommended fairly low-level approaches to development when you build Android apps. But going forward, the focus will be on these Jetpack components, so you'll have to create less code to make your app do what you want it to do. Android Studio is updated frequently, and it's very common, especially when working through these training courses, to open a project that was built in an older version of Android Studio and then have to adapt it for the newer version. I'm going to demonstrate some troubleshooting steps that could be useful as you work with these exercise files and with your own projects. From the welcome screen, I'm going to import an Android code sample. I'm going to filter on Kotlin and then scroll down to the Getting Started section. I'll choose this sample, named Basic Sample in Kotlin for writing unit tests. On the next screen, I'm going to shorten this project name, so it's just Basic Sample, and that creates a directory named Basic Sample, and then I'll click Finish to download and import the project. The first thing I encounter is that this project was built with an older version of Android. I'm working with Android Pie, that's API level 28, and this project was built with Android 27. I'll click this link to install the platform. After reading through the terms and conditions, I'll accept and click Next. And that will download the components that you need to build and work with this project. I'll click Finish, and now the rebuild starts again. And this time I'm told I need to install build tools. And you should just keep on clicking these links that are offering to upgrade your components so you have everything you need to work with this particular project. Now, the next dialog you might see is very common. Each time you upgrade to a different version of Android Studio, you also need to upgrade something called the Android Gradle plugin. If you see this dialog at any point, especially when you're working with the exercise files for this course, click the Update button, and that will make changes to your Gradle build scripts. Now, the next error I see has to do with Kotlin, and that's because this project's Kotlin version doesn't match my version of Android Studio. First, I'll go to Android Studio's Preferences or Settings, and then I'll go to Plugins. From here, I'll search for Kotlin, and I see that my version of Android Studio is using Kotlin plugin version 1.3.11. Depending on when you're watching this course, your version may differ. Now I'll go to my Gradle scripts directory and I'll open the Gradle script for the project. Now I see a different version of Kotlin is listed here. So I'll conform that so it now says 1.3.11 as well. And I'll click Try Again. The next error I see has to do with an inconsistency between how we used to declare Kotlin and how we do it today. To fix this, I'll go to my Gradle file for the app module, and down here, where it says JRE7, I'll change that to JDK7. And once again, I'll click Try Again. And now my project is built without any problems. If you're still seeing issues, here are a couple other things you can try. When in doubt, rebuild the project. Go to the menu and choose Build and Rebuild Project. And that deletes any existing artifacts that have stale code in them and rebuilds the project from scratch. If you're still seeing errors, you can go to the Gradle tab at the top right. Right-click on the project and choose Refresh Gradle Project. And once again, this is a step that will clean up a lot of problems in your Android projects. In Android, an activity is generally defined as something an app can do. In apps designed for phones and tablets, activities manage screens. An activity screen might not always look the same. It might, for example, only serve as a container for smaller user interface components named fragments. But on phones and tablets, each screen is always managed by an activity. This activity is named Main Activity, and as with all activities, it's registered in the application manifest. When the user starts an app by tapping its launcher icon, the app framework looks for the app's launcher activity, which is marked by this intent filter. The filter has an action and a category. The action is set to main and the category is set to launcher. Each application should have only one activity that's marked in this way. When you first create an application in Android Studio, regardless of which activity template you use, it'll always have a single launcher activity. When the user starts an app by tapping its launcher icon on the device, the application framework looks for the app's launcher activity, which is marked by that intent filter. The intent filter defines how the activity is going to be used. The framework looks at this and says, I need to start this activity. And it starts up this class, main activity, which can be programmed in either Java or Kotlin. The class is an instance of another class that is always extended from an activity class that's a part of the Android SDK. To find out about the inheritance hierarchy, you can hold down the Control key on Windows or Command on Mac, and then click the class. And it'll show you that this class is extended from Fragment Activity. And keep on clicking through the superclasses until you find the activity class. Now, this activity class is extended itself from another class called Context Theme Wrapper. And this is an important concept. Each activity is a kind of a context in Android. I'll be talking more about contexts later in the series, but in this beginning course, I won't touch on it very deeply. But it's important to know that each activity is one kind of context. The other kind of context is called the application context, and there are times when you want to refer to each of them, the activity context and the application context. So let's close down some of these files and go back to the main activity. I'll right-click on this tab and close others, and now I'm left with just that code. When the activity comes to the screen, the application framework calls a series of what are known as lifecycle functions. These are callbacks. That is, they're called by the app framework automatically using interfaces that the activity implements, and they're marked in your activity with the override keyword. The onCreate function is the most common one that you'll see, but in this activity class there are others, including onCreate options menu and onOptions item selected. Within the onCreate function, you'll see that the first task is to call the superclasses version of the same function. And then after that, typically you call setContentView and pass in a reference to a layout file. r.layout.activityMain refers to a file called activitymain.xml. And again, you can Control or Command click to jump to that file. This file is stored in the Resources directory under Layout, and you can jump to that location in the project window by clicking on this icon labeled Scroll from Source. So that's the entire startup process. From main activity, the onCreate function is called. Within the onCreate function, setContentView is called, and that loads the screen design, which is defined in the XML layout file. And I'll describe more about how layout files work in the next video. When an activity first comes to the screen, it loads an XML layout file by calling the setContentView function. The setContentView function takes an integer value that's the resource ID of this file. This expression, r.layout.activityMain, references an integer value that's assigned automatically and stored in a class named R. Now that class is auto-generated and you'll never make changes to it yourself. If you did find the class and change it, your changes would be wiped out automatically by a process that's running in the background as you code, that's generating that class. The resource ID for a layout file always starts with r.layout. Layout references the layout directory in the resources directory, and then ends with the name of the file without the file extension. Now you can jump to that file by pressing Control or Command and clicking the ID. And that'll take you to activitymain.xml. Over here in the project window, you can collapse all these directories and then jump to the location of the file by clicking on the Scroll from Source icon. This particular application template has two XML layout files. ActivityMain.xml is the outer file, and then there's a nested or included file called ContentMain. The floating action button, that's the button that appears in the lower right corner of the screen, is defined in the outer file so that it won't move around as the inner file scrolls up and down. But any changes that you want to make typically should be made in the nested file, ContentMain.xml. In this activity, the default content view file includes just a text view component. Now it's wrapped inside a constraint layout container. Constraint layout is one kind of view group, a component that's designed to manage the layout of multiple views. The text view is a child view. That is, it's a child of constraint layout, and its position is dictated by the four attributes seen here, starting with layout constraint. These four attributes reference the edges of the screen, the top, the bottom, the left, and the right. And they're all referencing parent. And that places the text view in the direct center of the screen. If I want to change that, I can go to Design View, then make sure I've focused on the text view component. Then over here in the attributes in the layout section, I'll click on this icon, and that gets rid of the bottom constraint. And now that component floats all the way to the top of the screen. If I want to position it a little bit further down, I could simply drag it on the screen, and that would generate the required code. Or I can come over here to the Attributes section, and I'll search for Margin. I'll find Layout Margin. I'll open this up, and right here I see Margin T. That's the top margin. And I'll set this to a value of 30. Then I'll look at the resulting code. I see layout margin top equals 30, And that's not quite right. In addition to the 30, I also need a suffix of DP, and that stands for device-independent pixels. I'll set that value in code, then look at this again in Design View, and see that the object is 30 pixels from the top of the screen. Now I'll search for an attribute called size, and I'll look for text size, and I'll set the text size to 36 SP. So notice that there are two different units of measurement being used here, DP for the size of a component and SP for the size of a font. So that's a very lightweight introduction to XML layouts. In Android, you build your screens using widgets known as views. When you're looking at a layout file in Design View, as I am, you'll see a palette component over here. The palette offers a series of views, each having a different function. For example, the text view, which I'm already using, displays read-only text. A button is something the user can touch or click to make something happen. An image view displays an image. A recycler view displays multiple components, and so on. In Design View, you can drag these objects into place. When you drop them in a particular location, it'll look like they're in a fixed location, but in fact, if you run the app, you'll see that the object will bounce back to the top of the screen. To solve that, you have to anchor the view. Now, when you create a brand new application in the most recent versions of Android Studio, the root element of your layout is called the constraint layout. This is a particular kind of view known as a view group. It's designed as a container that will manage the positioning of its child views. Right now I have a text view and I have a button. So here's one way to anchor the button. I'll select the button object, then I'll click on its anchor in the bottom center, and I'll drag it down to the bottom, and the button moves to the bottom of the screen. I'll go back to text view, and I'll move this code around so it's a little bit easier to read, and I'll see that I have a new attribute called layout constraint bottom to bottom of that's set now to parent. I'll go back to Design View, and now I'll anchor the object to both the left and the right borders. I'll look at the text and see what's been generated, and now I have two more constraint attributes, one for end to end of and the other start to start of. You'll also sometimes see left to left of and right to right of. The start and end versions are preferred because they can react elegantly when the app is run in a language that goes right to left. Now I'll go back to Design View, and I'll anchor the top of the button to the bottom of the text view. And now that button is in the exact center between the text view and the bottom border. Notice the number 8 here. That indicates that there's a bottom margin of 8 DPs, or device-independent pixels. You can do many other things with the constraint layout view group to manage the positioning of various objects. But there are other view groups available, and you'll find them under the Layout section. For example, the linear layout can lay out objects from top to bottom or from left to right, and the frame layout is designed to contain a single child view. There's an older layout you'll see in older applications called the relative layout, but that's mostly deprecated and is replaced now by the constraint layout. You'll find many other available views here. For example, the web view does exactly what it says, displaying web content. The video view displays videos. There's a calendar view, a progress bar, a seek bar, and so on. I recommend experimenting with many of these view components to see what you can do to design your Android app. Android supports the use of images in a variety of formats. You can use traditional web-based formats such as PNG or JPG files, but there are some better formats that are either smaller than those traditional files or are vector graphics that adjust elegantly to different screen sizes and pixel densities. To demonstrate the use of images, I'll start in my content main.xml file. This is the nested layout file. I'll change this text view in a couple of ways. First of all, I'm going to add a unique ID. Every view component that you want to refer to programmatically or within the layout file needs this unique identifier. The ID always starts with @+ID/, and then the ID should be all lowercase. Use underscores if you need to separate any words. I'm going to call this headline. Then I'm going to change this text to my favorite monster. I'll adjust some of these attributes so this is a little bit easier to read, and now I'm ready to display an image. You display images using a component called an image view. To display the image, go to Design View, then in the palette in the top left, drag an image view component into place. When you first create the image view, you can add a temporary image, so you can see what it might look like. I'll click on the avatar's sample data, then I'll choose one of these files, and click OK. Next, I want to position and size the component. I'll constrain the top of the image view to the bottom of the text view by clicking and dragging. Then I'll constrain the left and right sides to the edges of the parent component. And then I'll constrain the bottom to the bottom of the component. Now notice that the image is still square. If I want to stretch it, I need to change some settings. I'll go to the text view for this code, and I'll change both the layout width and the layout height to 0 dp. And that means to the constraint layout container that it can resize this object so that the constraints can be applied and the object can stretch. I'll make that change and then look at this in Design View, and I'll see that the image has grown. Now, I can try running this application, but it won't look exactly like you expect. That's because these temporary images that are provided by Android Studio aren't actually bundled into the application. And so when you look at the app on your device, you only see the headline. So now I'm ready to add an actual image. For this demonstration, I've added some files to this branch of the project. Notice that I'm in branch 0404, and under the project root there's an assets directory. And under there, a directory called Monster Images, and within those images, there are two formats. There's a set in PNG format and a set in SVG format. These are the same images, but just in two completely different formats. I'll choose monster01.png, and I'll copy it to the clipboard. Then I'll return to the Android scope, and I'll go to the drawable directory under RES for resources, and I'll paste that file into place. When you add a file, it automatically becomes a resource, and its resource ID is the name of the file without the file extension. Now sometimes, when you copy a file into place like this, it isn't always noticed, so to make sure it's compiled into the application, select Build, Make Project. Now go back to the text view of the layout file. And I'm going to get rid of this attribute, Tools Source Compat. That's the reference to the temporary image. And I'll replace that with Android:source. And I'll choose @drawable/monster01. And I'll look at that in Design View, and I see my actual image. And now when I run the application, I see the actual image show up. So that's how to get started with simple PNG and JPG formats. If you want to use more advanced formats, you have to do some conversions, and I'll show you how to do that in the next video. Android supports traditional web-based image formats such as JPG or PNG, but there are some more contemporary formats that it also supports that you might want to use. The WebP format is also a bitmap format, but it's compressed smaller than PNG files. And if your application has a minimum SDK of API level 18 or later, that's Android 4.3, then you can also support transparency. It's very easy to convert your existing PNG and JPG files. I'll right-click on my PNG file in my resources directory, and then down at the bottom of the menu, I'll choose Convert to WebP. Make sure that you've deselected the option to skip images with transparency, because this image does have transparency, and then click OK. And you'll see a preview of how your image will be converted. Notice that the resulting image will be much smaller than the original, and you can adjust the quality to get the results you want. I'll click Finish, and there's my new WebP file, and it looks exactly the same as the original. Back in my layout file, I don't have to make any changes, because remember that the resource ID only references the beginning of the file name and not the file extension. I'll run the application to make sure that the application looks and behaves the same, and there's the result. My image appears, and it's exactly the same format as the original PNG file. Now, if you like, you can also use an XML format known as a vector drawable. This is similar to traditional SVG files that work on the web, but Android doesn't support SVG. You have to convert those files using a tool in Android Studio called the Android Asset Studio. Now, in my project scope, I'll show that I've included these SVG files, and I'll double-click to open the SVG file, and Android Studio successfully previews it, but again, I wouldn't be able to use this file directly. So I'll go back to the Android scope, and I'll go to the app module and right-click, and then choose New Vector Asset. I'll browse and locate my SVG files, and I'll choose that file. And then I have a couple of options. I can set the size to a square aspect ratio. In an image like this that originally wasn't square, that would distort the image. Alternatively, I can click the Override checkbox, and then the image will look the same as it did before. I'll click Next and Finish, and that creates the new file that's now called ic_monster01.xml. To make sure that that file's been registered, I'll select Build, Make Project. Then I'll go back to my layout file, and I'll change the file that I'm looking at from Monster01 to IC_Monster01. I'll look at that in Design View and see that Android Studio recognizes the format, and then I'll run the application on my device to make sure that everything still works as it did before. Vector drawables aren't any smaller than the WebP format. In fact, in many cases, they're larger. But they're more flexible in that as vector graphics, they automatically adjust to the size and pixel density of your screen without distorting the images as bitmaps might. These two formats, WebP and vector drawables, give you a lot of flexibility, allowing you to choose between the smallest possible file or the one that resizes most elegantly. In order to navigate from one screen to another in an Android app, you'll create something called an intent. An intent is a set of instructions. Each intent can include an action, typically expressed as a constant, but it can also include arbitrary data values known as extras. In order to navigate, create an intent that references the current activity as a context and the desired target activities class. The application framework is responsible for interpreting the intent. It creates an instance of the target activities class and then loads it, and the user just sees the new intent screen appear. To demonstrate this, I'll create a new activity. I'll start in my Android scope and I'll right-click on the app module. I'll select New Activity, and I'll choose Basic Activity. and I'll accept the activity name of main2 activity. And I'll set it as a launcher activity. This is going to become my new primary screen. And I'll click Finish. Now, when you create the new activity, Android Studio automatically registers it in your application manifest. I'll go to the manifest, and I'm going to deal with this warning that's covering the entire content here. I'll place the cursor after the application tag, then I'll hold down Alt or Option and press Enter or Return, and select Add Tools Ignore Google App Indexing Warning. And now I can see the code clearly. Notice that both my new activity, main2 activity, and my original activity, main activity, are registered as launcher activities. I'm going to delete the intent filter from the original activity, and I'm going to add a new attribute called parent activity name and set it to main2 activity. I'm now saying that the primary activity is main2 and the secondary activity is main. I'll clean up this code a little bit more. And now I'm ready for the next step. I'll go to my new class, main2activity.kt. When the user clicks on the floating action button in the lower right corner of the screen, I want to respond by navigating to my new activity. That's happening right here in the Set OnClick Listener function. I'll delete this code that's displaying a snack bar message, and instead I'll create an intent object. The code will look like this. Val intent equals intent. In Java, you would use the keyword new, but in Kotlin, you don't need that. I'll make sure that I've imported the intent class, and then I'll pass two values into the constructor. I'm going to pass in a package context, and that'll be this, the current activity. And then I'll pass in the class of the activity I want to navigate to. And that'll look like this, main activity, class.java. In Java, you would just say .class, but in Kotlin, it takes a bit more code. Now my intent object has been created, and I'm ready to pass it to the application framework. I'll call the function startActivity. And I'll pass in the intent object. And I'm ready to test the application. When the application loads, it initially displays my new main2 activity. I'll press the floating action button, and I jump to my original activity. I can then press the back button, and I return to what's now the main activity, and pressing back again takes me to my launcher screen. There are newer approaches available for managing navigation between screens, including the new Navigation Architecture component that I describe in this course in the library. If you're getting started building applications for the first time, it would be worth exploring this architecture component to see if it represents the way you want to build your application. But it's essential to understand the lower level approach that I've shown in this video. In many cases, you'll want to manage navigation yourself using your own intents. When you load a new activity with an intent, you can share data with the new activity in a number of ways. To demonstrate this, I've rebuilt this application a bit. The main activity is much simpler than before in terms of code, but in its content layout file, I'll jump to that file here, I've added 4 buttons, each displaying an image. These are using a particular kind of component called an image button. And you can see in the text that I'm referring to the image that I want to display right down here in the source attribute. The first button has an ID and source of monster01, the second of monster02, and so on. When the user touches or clicks one of these buttons, I want to jump to the detail activity and display the selected image full screen. Now, to respond to those clicks or touches, I'm going to refer to the ID of the button. I'll start here in the main activities onCreate function, and I'll choose Monster01 from Content Main. When I choose that ID, I'm automatically adding this import. This import is examining the contents of the layout file and automatically generating the resource IDs I need. From here, I'll call .set onClickListener. And I'll get rid of these parentheses and instead use braces. And I'm going to call a function that I'll need to create called viewMonsterImage. And then I'll pass in the ID of the Monster01 image. I'll come back to this function call, and I'll use an intent action. Press Alt and Enter or Option and Return, and create the function here. And this is where I'm going to put all of my code. First, I'll need an intent object. I'll call it intent, and I'll instantiate it with intent. I'll pass in this as the context, and then detail activity : class.java as the class of the activity I want to load. I'm going to change the name of this argument from Monster01 to MonsterID, and I'll make sure that I've imported the intent class. Now I'll set the action. An action is a string, but typically you use a constant value that's defined in the intent class. I'll call intent.setAction, and I'll pass in intent, and then I'll type view here in uppercase, and that'll take me to the action view constant. And then I'll call start activity, and I'll pass in the intent object. Next, I'll load detail activity. I'll press the Shift key twice for search everywhere, and I'll start typing detail activity, and there it is. Notice that I already have an import here for the content detail layout file that isn't being used yet. I'm going to need that later, so I'll leave it alone. Right here in the onCreate function, I'm going to log the action that's received. I'll use the log class, and from there I'll use a function called I for information. And I'll pass in a string of intents. That tag is used to filter the logcat messages in Android Studio. And then I'll pass in the following message: action equals, and then I'll put in a $sign and a pair of braces, followed by intent.action. In Java, this expression would be more verbose. It would be getIntent and getAction as method calls. But Kotlin lets you use simple property syntax. Now I'll test my code, and I'll see what happens. While the app is loading, I'll set up my logcat window, and I'll make sure that I'm filtering on the intents tag. Then I'll come back over here to the application. I'll touch the button, and that loads the detail activity. But more importantly, I'll come back to the logcat view, and I'll see that I've received the action. So that's the first way to pass some information from one activity to another, using actions. And in the next video, I'll show you 2 other ways to pass data that's much more detailed. When you start a new activity with an intent, you can pass an action, as I showed previously, but you can also pass much more detailed data. There are a couple ways of doing this using either the data object of the intent, or you can pass data extras. The URI is a single property, and it's a strongly typed uniform resource identifier object. Here's how you create it. I'll place this code before I call start activity in the main activity class, and I'll create a new object that I'll call URI, and I'll use the Java URI class from Android.net. From there, I'll call the parse function, and I'll pass in the string. Typically, this is a string that looks like a URL, so you start with http:// and then add your base package. And for me, that's com.example.myfirstapp. Next, you can add one or more virtual directory names, and these will constitute the action that you want to pass. I'll use view. And then you can add a query string. I'll put in a question mark and say ID equals, and then I'll pass in the monster ID variable. In Kotlin, the $sign means add a variable value here. And if it's not a complex expression, you don't need the braces around it. Next, I'll take that URI object I created and assign it to the data property of the intent object. Now I'll come over to the detail activity. Here, I'll find out what my action is by getting what's known as the last path segment of the data object. I'll create a variable called lastPart, and I'll use intent.data. I'll add a question mark there because that means I don't know if that's a null value. And from there, I'll call last path segment. Next, I'll examine that last part. When I examine it, I'm going to add a double exclamation, and that's an assertion that that variable isn't null. And I'll ask whether it equals the value view. And then if it does, I'll extract the monster ID using a getQueryParameter function. Once again, I'll use the question mark after intent.data to indicate that it's a nullable expression. Then I'll call getQueryParameter, and I'll pass in the string ID. And then once again, I'll log some information to the logcat window. This time, I'll trace the query parameter, and I'll run the application and see what happens. I'll touch the button and jump to the detail activity. Then I'll come back to Android Studio and look at my logcat window, and there's the result. I'm still seeing my action, but now I'm also getting the query parameter, and that's a dynamically assigned integer value that represents the resource ID for that particular image in the drawables directory. You can add as many query parameters as you need to pass all the data you want. And then the third way to pass information between activities is to use intent extras. An intent extra is a key value pair, where the key is a string and the associated value is strongly typed. It can be a string, a number, or any other primitive type that's supported by Java and Kotlin. Back in my main activity, I'll call intent.putExtra. Notice that there are many versions of this function. They all take a string as the key and a value that has a particular type. But the actual version of the function will be inferred by the value that I pass in. So I'm going to say intent.putExtra, and I'll pass in a key of monster ID, and then I'll pass in the monster ID variable that was passed in up here as an argument. And that's all I have to do to pass the data. Now I'll receive it in the detail activity. I'll say val extra ID equals intent.extras. I'll add a double exclamation here because if that expression returns null, this operation won't be possible. From there, I'll call getInt, and once again, I'll pass in monster ID, and then I'll call log.i once again. I'll pass in intent as my tag, and then extra value equals, and then I'll pass in extra ID. In the app, I'll touch that button again. I'll come back to Android Studio and look at logcat. Now I see that the extra value is exactly the same value. So now I have these values. What am I going to do with them? Well, I'm going to use that value to dynamically load the image that was selected. I'll look at my activity layout. And I'll notice that my image view has an ID of monster image. I'll come back to detailactivity.kt, and notice up here I still have my import for the content detail, and that'll make it possible to directly reference the monster image object. I'm going to call a function from the monster image called setImageResource, and I'll pass in extra ID. I'll come back to the main activity class, and I'm going to duplicate this line 3 times, because I want to respond to button clicks from any of those 4 buttons. I'll change the IDs of the buttons, and I'll also change the IDs of the graphics I want to load. And then I'll once again run the application. When I choose the first button, I see the first image. I choose the second button, the third, and so on. So now my application is interactively allowing the user to select the image they want to see in full screen size. And of course, you can pass any sort of data from one activity to the next. You can use actions, you can use URIs as data, or you can use intent extras. When you send data from one activity to another using an intent, that's called an explicit intent within your application. But when you pass data from application to application, that uses something called implicit intents, an intent that sends the data without knowing which application or activity is going to handle it. Your own application can register to handle these kinds of intents. You do this in the application manifest. I'm going to set up my detail activity so that it can receive data from other applications on the device, and specifically, it'll be looking for simple text. It'll translate that simple text into a request to display a particular image. I'll start in my manifest file, and I'll turn my detail activity declaration into an opening and closing tag. Then I'll make a copy of this intent filter from the main activity, and then I'll paste it into the detail activity. I'll reset the action and the category's names. When any application sends simple text for handling by any other application, the action is always send. And that equates to a constant in the intent class of action_send. The category instead of launcher will be default, uppercase. And then I need to indicate what kind of data I want to receive. I'll create a data element, and I'll set the MIME type to text/plain. So now I'm saying whenever any other activity on the device sends simple text, my application is capable of handling it. Next, I'll go to my detail activity, and I'll add some code to stop the processing that is currently handling from activities within the application. I'll place this code right here above the log output, and I'll add an if clause, and I'll examine intent.action. And if that matches intent.actionSend, I'll simply return. I don't want to do all the other processing because I'm not coming from the main activity. Now I'll do an initial test of this by running the application on the device. That will load the application, and it'll register this new intent filter. On the device, I'll back out of the application, and then I'm going to load the Keep application, where I've created a simple note that has a bit of text, the name of one of my images. I'll go to the menu, I'll choose Send, and then Send via Other Apps, and there's my application. It's been registered. I'll select it, and right now I'm simply jumping to the detail activity, but I'm not doing anything with that text. So let's go back to Android Studio and make some more changes. I'll go to the detail activity class, and I'll add code here before the return statement. When another app sends simple text, it will arrive as a string extra with a key of extra_text, and that's a constant of the intent class. So I'll add this code. I'll say val monster equals intent.getStringExtra, and I'll pass in the constant intent.extraText. And I'll log that. The message will be useSelectedMonster and then the variable monster. I'll load that app onto the device. I'll back out of all the applications. Then once again, I'll go to Keep. I'll send the text to the application, and then in Android Studio, I'll look at Logcat. I'll filter on intents, and I see that I've successfully received that text. Now I want to use that text to get the equivalent resource ID. I'll create another variable that I'll call monster ID, and I'll use this expression, resources.getIdentifier, and this is a function with 3 arguments. The first is the variable itself, and I'll use monster ? And then I'll call the trim function, because when I receive this text in the intent, it might have a trailing hard return or extra space. Then I'll pass in the type of resource this is, and that's drawable, lowercase. And finally, I need to pass in something called the package name. This indicates where the resource is stored in the resources class. Now, just as I did in a previous video, I'll call setImageResource, and I'll pass in that ID. And then again, I'll return because I don't want to continue processing. So all this code is only for when I receive data from another application. I'll once again load the app onto the device. I'll back out of it. I'll reload my Keep application. I'll send the data, choose my application, and now I'm seeing the image that the user requested. So now my app can receive and handle plain text sent from any other app on the device. But what I do with that text is entirely up to me.